Okay, hello everyone. So these two problems I have discussed in the last class, but most nobody has answered this clearly in the chat box. I was expecting some answers from you, but I don't know whether it's a basic problem that you don't know how to calculate the numericals, or you don't know the basics of your machines or networks. So I'll be solving this. So this in this problem we have calculated, at least you should have calculated that gamma will be that 180 degree is my phase, uh, per this is 180 degree slot per pole. So slot per pole, if you put here, this is 90 divided by 10. So 90 divided by 10, so you will be able to get these two cancel, so you will be able to get that 20 degrees the slot angle, right? So similarly there was it is coded by one slot, so kd will be cos alpha is nothing but 20 degree cos alpha by 2. So that will be your cos alpha by 2, that will be 10 degree cos 10 degree, so it will be 0.984. Okay, similarly for calculation of m, if you have calculated slot per pole per phase, so slot per pole per phase, it will be 90 slot per pole is 10 and per phase is 3. So if you have calculated this m, it will be 3. Slot per pole per phase is 3, so k, sorry, this will be kp and this will be kd will be sine m. M is 3 sine m gamma is 20 degree and divided by 2, and again whole divided by m sine m is 3 sine gamma by 2, so 20 by 2. So here if you would do it, it will be 10 degree, so it will be sine 30 degree by sine 10 degree, right? Sine 30 divided by 10 degree, it will be 0.959. The answer is 0.959. Okay, now simple, you have to put the value. This is an 11 kV, so you have to put 11. This is your line to line voltage, so you have to convert 11 by root 3, that is your line to phase voltage. So 11 by root 3, that is equal to 4.44 into f is 50, phi is given 0.11 Weber, kd kp is 0.984, and then kd is 0.959. 4.4 for f phi kd kp into turn per phase, that is turn per phase. So if you put the value, if you equate this, you will get turn per phase as 275.59. 275.59, this will be your number of turn per phase. So if you calculate this 11 kV, it is kV, right? So always the mistake you would have done is 11 kV, so you have to take 11,000 by root 3, so it will be around 6,350.8. This will be, you have to equate this, then you will get this thing, 275.59. So most of you would have been done the mistake here. Okay, so this you do it by yourself and try it. This is an important problem. So next problem we have discussed in our last class is this. So a three-phase star connected synchronous generator has 750 RPM, generates a line-to-line voltage. This thing. So slot per pole per phase. So here, here we will do that M, it is given as 2 slot per pole per phase. So first calculate slot angle. Here we have calculated slot per pole will be 2 into 3, that is your 6. So this is 2 slot per pole per phase multiplied by phase, so 3, that is 6. So slot angle will be 180 degree divided by slot per pole, that is 6, so you will get 30 degree. So this is your slot angle, right? Okay, now here it is already said that the it is a full pitch coil, so kp is no doubt it is 1. Now you have to focus on kd calculation. Kd sine m, m is 2, gamma is 30 divided by 2 upon 2 sine 30 by 2. So that is your, and this will give you 0.965. 965, this is your 965. Okay, now here one more thing we have to calculate is how much is the turn per phase. Turn per phase, how much is turn per phase? I expected that you must be able to calculate this, but nobody has calculated turn per phase, so the basics is very weak. So don't expect that you will be a good at electrical engineering. Now how to calculate a turn per phase here? Now first, if you see, if a basic thing is how a turn is made up of. So this is slots, and this is two conductor. So the slot, so this is one turn. So this one turn, how the turn is made, it contains two slots, two conductor and two slots makes one turn, right? Now always remember, two slots makes one turn. So first calculate how many number of how many number of slots are there. So it is said that slot per pole is 6. Here, from here slot per pole is 6. So if we have already calculated the number of poles from 120 f by p. So it is already given 120 f. So the speed is given 750 rpm, right? So 750 rpm is equal to 120 f. F is 50 hertz by p, number of poles. So from here you will get poles is equal to 8. Number of poles is 8. So how many slots are there? Slots will be 6 into 8. 6 into 8, that is 48. So number of slots is 48. So total number of slots is 48, but two slots makes one turn. So right? So how many number of turns will be there? Two slots makes one turn. So 48 divided by 2. So this is one turn, right? Sorry, one coil. One coil. This is one coil. Two turn makes one coil, right? Two slots make one coil. Okay, two slots makes one coil. So there is total number of slots is 48. So total number of coils is 24. Okay, multiplied by each coil has 4 turn. Each coil has 4 turn. So this is the total number of turn. But we have to calculate total number of turn per phase. So we have to divide by. So how many number of phases there? 3. So this will be giving you 32. So total number of turn per phase is 32. Again I am repeating it. Just remember, Two slots will be giving you one coil, right? So first calculate the total number of slots. So slot calculation 48. 48 is the total number of slots. So two slots makes one coil. 48 divided by 2. That is 1. This is the number of coil. And this is the number of each coil has 4 turn. It is given here. Each coil has 4 turn. So 4 turn. And per phase is divided by 3. That is per phase. So that is 32. So this is the whole thing. Okay. Now next, what you have to do? You have to just put the values. So we have calculated the number of turn, the number of thing, and now here we have again you have to put the values. For again the same formula, EB is equal to 4.44. Now if you check here, EB is 440. 440 watt. It is a line to line voltage. So for you have to go for phase voltage, line to line into phase. That is root 3 division, right? Equal to 4.44 F. F is 50. Phi we have to calculate, phi into phi M, phi KD. First go for KD. KD is 0.965. KP is 1 because full pitch, and then turn per phase, that is 32. So you will calculate this, you will get phi as 0.0337 Weber. This is the unit. Okay. So these are the two things, problems, simple problems we have done. One more problem I'll give you, and this problem is you have to do by yourself. A 6 pole 50 hertz alternator has 42 slots with 2 layer winding. Now the layer of winding is 2 layer. So this one thing is complex here, that this single layer winding is, each slot contains 2 conductor now. Okay, so this is 2 layer, double layer winding is there. Now let's see how you are able. This is one. So each, you can say that each coil, each two, what you can say here, two slots, two slots will give you two coil, right? Two slots will give you two coil. Double layer winding is advantageous here because two slots will give you two coil. Previously it was one coil. The flux per pole is 0.12 Weber and each full pitch coil has 8 turn. The line to line EMF when the coil are connected for two phase connection and three phase connection. The options are given here. You try it by yourself and give your answer. I expect again people should answer this. Remember there is a two phase. So always when you are calculating slot per pole per phase. Okay. So per phase in two phase connection it will go for 2. In three phase connection it will go for 3. So let's see how many be able to calculate the EMF. If you are able to calculate, it will be your basics is clear in this. Okay. Thank you.